Welcome to the lecture on rolling processes. So, we will discuss about classification and hot and cold rolling in this lecture. So, rolling is a very important process of deformation in the most of the plants. If you talk about the plants, there you get the blooms or billets which are produced in earlier days. They were all produced in the rolling mills. So, basically once you have the ingot, as we discussed earlier, that in the case of metalworking processes, when you find the ingots have a lot of defects. They are possible defects in those cases. So, basically they need to be eliminated, and that is why these metalworking processes are important, that these ingots were to be converted into the usable products. So, the usable shapes which are further used for making the final product. So, in the intermediate you have to convert them into blooms, slabs or billets, and then these blooms, slabs or billets are converted into further the sheets or plates or so. So, this process is done by the use of rolls. So, you have the rolls made of very hard material, and the material is basically the ingot or slabs or so. They are basically pushed in between the rolls. So, what happens that from one side the ingot or the slab which goes in between the rolls. So, for that the thickness of this ingot or the slab is more than the gap between the rolls. So, otherwise they cannot move, but then when there is rotation given to the roll, then and also there is friction at the surface of the roll and in between the metal which is to move into it, then because of the friction it is going inside that roll. So, the principle is that you have two rolls. So, there is a roll here and there is another roll which is here. So, these rolls are there, they are it is not very round. So, I will try again further to make a better. So, you have this center line. So, you have again you have coming as this center line. So, you will have like this. Still it is not so good, but still okay. Now, the thing is that you have a product which has to go from here, its thickness is this one. So, this is the thickness. Now, this can be, its thickness can be reduced, and once it will go in between the rolls, then it will come out of this thickness. So, it moves in this fashion, and ultimately this will be of in this fashion it will go. Now, the thing is that when we use these rolls, so these are the rolls. So, these are known as rolls, and this is the stock. So, this stock can be of anything. It may be an ingot, it may be a slab, or it may be billet or so, blooms or so. So, now that this ingot, suppose you have got this is put here, and depending upon the degree of reduction, you will have to maintain the distance between these rolls. So, that also again depends upon the coefficient of friction between the rolls and also the stock material. So, it will not go otherwise inside it. So, what is done is it will be moved. So, basically this is given. So, if this being the center, this is the center of the rolls. So, it is given a movement to this roll. So, this will be moved in this direction and this will be moved in the opposite direction. So, because of that, once it comes and touches here, because of the frictional forces, now it will try to take this in between the rolls. So, it will go there, and then once it goes into this range, then here it gets plastically deformed. So, because of these stresses which are there on this, so there is compressive stress which is acting on the surface of this stalk, and then it moves into this direction. So, basically this is known as angle of bite. So, that you must have taken these courses earlier, that these are the rolls, this angle which is there, which is formed, this is known as angle of bite. Then how much can be the degree of reduction, basically that also is a factor of what should be what is the frictional value. So, that frictional coefficient of friction at this surface. So, this is how rolling takes place. So, process of plastically deforming the material by passing it in between the rolls is called as rolling. So, that is the definition of rolling. Now, workpiece is subjected to high compressive stress because there is squeezing action of these rolls, and the stock is basically squeezed in between the rolls, and the surface shear stresses are developed here, and because of that the material fails. Okay, so this is developed because of the frictional forces which are present at the surface, between the surface and so because of the friction between the surface of the stock and the roll. So, here this friction is generated. So, because of that surface shear is formed, the surface shear forces are generated, and then that basically shears or plastically deforms the material. Now, the initial breakdown of ingots to blooms or billets is by hot rolling. So, now again in the case of rolling, you have hot rolling as well as cold rolling. So, again it is same as the hot working and cold working temperatures. So, hot working will be for roughing purposes, initially for decreasing the dimension from larger to smaller. So, for that these hot working operations are carried out, in that you will have different passes will be there. So, from ingots to blooms or billets is done by hot rolling. So, which is further hot rolled into plates, rods, bars, pipes. So, you have first conversion from the ingots, because ingot is of larger dimension. So, you will have the ingot converted to blooms or billets, and then you have the billets or blooms or slabs, they are converted to plates, sheets, rods, bars, pipes. So, they are again the use of hot rolling, or you may use also cold rolling, because again it depends upon what kind of property you need. Cold rolling normally is used for making strips, sheets and foil. So, cold rolling, as we discussed in the past, that cold forming or cold working normally gives you better finish. So, whenever the reduction is important, degree of reduction is required, you go for hot rolling, and when the finish is required finally, or the finally you have to go for very final finishing, in that case you go for the cold rolling. So, in cold rolling, again cold roll anneal cycle will be there. So, that way you will have. Now, once we have this ingots, then you have the different products which is basically formed by hot rolling of the ingot initially. Now, from the ingot you get first the blooms. So, in the case of blooms, cross sectional area is greater than 230 centimeter square. So, ingot will be first. So, you can get blooms. So, in the case of blooms, normally you have width will be somewhat nearly to thickness, and cross sectional area will be somewhat around 230 centimeter square. So, that is bloom. So, 15 by 15 of square or so. So, that will be known as bloom. Then you have further you can have the billets from inlet. From the ingot you can have blooms you can have the billets. So, billets normally have the cross section of 40 mm by 40 mm. So, other products which are from the ingots are billets. So, whose in this case cross section is normally 40 mm by 40 mm. Then apart from that, you have the slabs. So, slab, blooms and billets, these are the normal products which you get from the ingots. So, slabs are normally cross section more than 100 centimeter square. So, in the case of slabs, the cross section will be normally more than 100 centimeter square. So, you have billets which are very small, then you have slabs, then you have blooms whose cross section is even larger. So, more than 100 about centimeter square, and width will be larger in the case of slab. So, width will be in the case of slabs, width will be somewhat more than 2 times thickness. So, if you take about 100, so it will be something like width will be 14 centimeter and it will be thickness will be 7 centimeter. So, that way you will get close to 100. So, something like 15 and 7.5, something like that, 15 and 7 or so. So, this way these are the 3 products which are basically formed by the hot rolling. Nowadays, basically because of the other advancement in casting processes, you can get these formation of these slabs and billets directly from the continuous casting units by casting itself in the copper mold. So, getting directly. So, that basically decreases a lot of these rolling operations or intermediate operations in between. So, that gives you this formation of these slabs, blooms or billets. Then the next is from after that these billets, slabs or blooms, they are the ones from where again further you go and use these billets, slabs or blooms further to make these plates, seats, rods, bars or pipes. These are used further in the plant. Now, again you have plate and seat. So, plate and seat are, as we know that in this case also thickness becomes quite less. So, we define plate as the one which has more than 6 mm thick. So, you have plate and you have seat. So, plate is having more than 6 mm thickness and the seat is having thickness less than 6 mm, but then width also is the one criteria. In the case of, so this is plate and then you have seat as well as strip. So, plate is okay, plate is the one which has 6 mm thickness, and seat and strip both have the thickness less than 6 mm. Thickness less than 6 mm. Now, in the case of strip, the width should not be more than 600 mm. So, that is what the case is. In the case of a strip, thickness is less than 6 mm and width should not be more than 600 mm. So, this is normally the definition of different kinds of the rolled products which we see in the industries. So, apart from that you have different kinds of rolling. So, by definition, rolling means that process in which we use the rolls to basically deform a particular stock and reduce its thickness and get the product later on. The product will come out of the rolls. the thing is that apart from that, this rolling is the use of rolls. So, normally we use these solid products, solid material which is in certain shape, and we push them in between the rolls. But we have also some rolling processes, like you have powder rolling. So, in the case of powder rolling, what we do is the powder is used basically. So, metal powder will be introduced between the rolls, and then you will have a green strip formed. So, that will be further sintered, and then that will be further processed, and you get the sheet basically. So, you will have the green strip formed once you put the powder and pass in between the rolls. So, and then you have a green strip that will further be treated, hot worked or cold worked and annealed. I mean, that cycle is followed to get the final product. Similarly, there is another type of rolling, that is thread rolling. So, in the thread rolling, basically the metal will be passed in between the grooves, and then in that die itself you have the shape for the thread making. So, once it comes out, it will have threads formed on that. So, that is known as thread rolling. Then you have also roll forming. So, we have thread rolling, that is by forming, and then after the another variety is the roll forming. So, what we do is that you basically it is a special kind of cold rolling in which the strip will be passed in between the rolls to have some complex shapes. So, you know, here thickness does not appreciably change, but the shape basically you get of different forms. So, that is why you have the term known as roll forming. So, thickness is not much of, there is not much of the change in the thickness, but then you get the you know, you are basically passing it through a series of rolls, and you get irregular shaped of channels by the use of this roll forming processes. Now, we will talk about the roll mills. So, they are also known as rolling mill. So, this rolling operation is done in the plants in certain shops, and these shops are known as rolling mills. So, here you have these you know, rolls, then a rolling mill will have the rolls, it is wrongly written tolls. So, it will be rolls, and so you will have rolls, then you will have bearings to support that rolls, you will have the drive for applying power to the rolls and controlling the speed of rolls. So, that is how a rolling mill will be defined, because basic purpose is to feed the stock or the slab or the you know, ingot. So, for that you must have the rolls at its own position. So, you will have the bearings to support the rolls, then you will have to have the drive which should be applied. We will be applying the power to the rolls to rotate it. So, to rotate in opposite directions in between the rolls are moving, and also the controlling the speed of the rolls. So, you can control it. So, for that you must have that, and then it must be housing which should be there. So, this way you will have rolling mills. Now, rolling mills are of, you know, different types, like you have simplest is the 2-high mill. So, 2-high mill means you will have 2 rolls. So, there will be 2 rolls of similar diameter, and then the metal will, the stock will go from one side, and it will pass after getting deformed, and while it comes out, in that case its thickness is now basically equal to the gap between the 2 rolls. So, this is the simplest type of rolling operation. So, that is what we had seen earlier, that was a case of 2 high rolling mill. You have one roll and then you have another roll. So, it is not very good circle which is drawn. So, you can have one roll, you can have another roll, and then the metal will come from here, not that way. So, you will have like this. So, this way it comes and then it goes from here. So, basically now this is coming like this and this is going like this. This is the center of the rolls, and as we discussed that it has to be rotated like this and this has to be rotated like this. So, this is known as a simple 2 high rolling mill. Then now you may have the 2 high reversing rolling mill. In that, basically the work can be passed back and forth through rolls. So, suppose this is the similar roll, but if the objective will be further, once you have passed it through this, and then if you can further change the direction of the movement of rolls. So, in that case the same thing can further move, and if the reduction, there will be reduction in the gap in between the rolls, then it can further be reduced, its thickness can be further reduced. So, that is known as 2 high reversing type of rolling mills. So, in that basically you will have both kind of movement possible. So, you will have once you move like this and then further. So, while taking this and you can further move like this. So, for movement in this direction you need to see that the rolls move in this fashion, and for moving again in the opposite direction the rolls have to move in this direction. So, this way this is known as 2 high reversing, 2 high reverse rolling mill. So, that is the 2 high reversing type of rolling mill. Then another rolling mill is the 3 high rolling mill. Now, in the case of 3 high rolling mill, you will have 3 rolls. So, in that basically these two rolls, these topmost and bottommost rolls are the driven rolls, and this is the roll which basically is driven because of the friction between these rolls. Now, if you look at the direction of rotation between these rolls, so if suppose this is the roll which has to move in this fashion. So, if it has to move in this fashion, then it has to rotate like this, so that it takes the stock in between the rolls and then it moves here. Now, after that it is moving in this direction. So, now from here this stock will come in this fashion and then it will come out as this. So, it will be further moving like this and this will be moving like this. So, in this way if you look at this, so this will be moving like this and this will be moving like this. So, this will take from this side and it will go like this. Okay, so, as you see this is opposite to this and this is opposite to this. So, this or this will have the similar kind of movement. So, this is known as 3 high kind of rolling mills. Now, you have it is seen that many a times when you use the smaller if you try to rotate the smaller rolls, then there is need of small power requirement. So, many a times you try to use very small rolls for the deformation, but then they require the support. So, for that there are backup rolls. So, there are one backup roll supporting one of the roll. So, ultimately what is there, that you have small rolls for deformation, but then they are basically backed up by the supporting rolls back. So, these are known as backup rolls. So, such kind of roll arrangement are known as basically the 4 high rolling mills. So, this is known as 4 high rolling mill. Now, in this case, suppose this is coming like this, so it will have the movement in this fashion, and similarly if you have the movement this as this one. So, if it moves in this fashion, it will move in this fashion. So, it will move like this. So, it will move like this. This will, so this will move like this. Similarly, this is moving in this direction. So, this is moving in this direction. So, this is moving in this direction. So, like that you will have. So, one will be your, this will be the working roll, which is doing the, these are the smaller ones, and then you will have the larger rolls for this, for giving the rigidity or for giving the support to this. So, they are known as backup rolls. Then you have sometimes rolls known as cluster type of rolls. So, in the cluster type of rolls, again you will have a roll which will have the support, like, so there are 2 rolls which do, and it will have the support like in this fashion, and then they will have further support in this fashion. So, similarly you will have the rolls initial support like this, and then they will have further support like this. So, these are known as a cluster rolling process. So, this is known as cluster mill. Cluster type of arrangement is there. So, again you can have the movement of rolls in that, and accordingly the movement of the rolls can be maintained. So, because of this is the primary movement of the rolls. So, this is known as cluster type of movement. You have also planetary type of rolling mill. So, you will have in that, so you will have planetary rolling mill. So, in that what happens, you have the planetary rolls, so which are there on this attached like that. On the whole the periphery you have this way rolls attached, and basically they are responsible for doing. So, the roll, so the job which is there, which is coming in contact, now this planetary roll is there. So, the job which will come in between, it will be deformed. So, again you will have one kind of this. So, you will have rolls attached here. So, you can refer these figures from the standard books. So, you have such kind of arrangement which is there. So, in that case this is known as planetary rolling mill. Okay. You have also formation of continuous strip maybe sometimes, and that is the continuous strip making rolling mills. So, in that what happens, if suppose you have a roll and then you will have the movement, and then what happens now here you will have the support of, when the rolls are there. So, you will have the rolls and then finally you will have, this is basically this is for coiling. So, what we see, this is a kind of continuous strip making rolls. Now, in this what happens, you will have this is a these are the strands. So, basically you will have further this way, you will have the rolls, these are having the different rolls, and these are known as a strand. So, if you look at this is strand 1, 2, 3 and 4. So, these are the 4 strands. So, we call it, so here what happens, you have a uncoiler here, this is known as uncoiler. So, basically this releases that coils, just like a coil, so it will release the sheet, and then from that it will go successively through these strands where the rolls are there in between, and then ultimately when the thickness will be quite small here, then after that it will come and it will get here wind up. So, that is basically known as wind up coil. So, this way the use of these mills are used, I mean, for the formation of the rolled products in the rolling industries. Thank you.